Hi folks, this is question 8. Here we have to give the dimensions of the rectangle. What we need to understand here is that this rectangle is basically just being opened out. It's like if you made a little cut down there and then you opened it out on both sides, it would just leave a rectangle there. So the width of the rectangle is just going to be the same thing as the height of the cylinder. So the height of the cylinder is 15 centimeters. That's going to be the width. Then the length is a little bit harder to see. If you imagine you opened out that cylinder, it'll actually be the same. This bit here, the length will be the same thing as what the circumference is. All of that circumference is just opened out there. So we have to go find the circumference, which is 2 pi r. So we do 2 times pi times the radius of the circle at the top. So the circle is 5 of the cylinder, and that gives us 31.4. So 31.4 is the length of the rectangle, and 15 is the width. Part B then, it's a cylinder inside a sphere. We're looking for the volume of the sphere. The formula for that is 4 over 3 pi r cubed. You get that in the log tables. So the only thing you need to fill into that formula is the radius. So we need the radius of the sphere. Yes, the height of the cylinder is 22. You're going to end up making a right angle triangle here. From the edge, where the edge of the cylinder there meets the top end of the sphere, we're just going to draw a line from the center, and then if I draw another line up to where the top of the cylinder is, so imagine that's the top of the cylinder in there, that has to be 11 then, because the height of the cylinder is 22, so therefore half of it is 11. And then this bit here, this would just be the radius of the cylinder. So the radius of the cylinder is, well, the diameter is 12, so the radius has to be 6. Therefore, I'm going to use Pythagoras to get what this bit is here, the x. So x squared is equal to 6 squared plus 11 squared. I should use r there instead of x really, because it's the radius we're looking for. Therefore r would be equal to, so you used to do 6 squared plus 11 squared, and then we're going to square root at the end. So root 157 in the end. Therefore the radius is root 157. I'm just going to put that in. I'll leave it like that because we'll get a big long decimal if we put down what it actually is. So root 157, and then we're going to cube that, and then in the end that should give us 8240.2 centimeter cubed. Right, part C then gives us these diagrams. The first part is just saying why CBD is 90 degrees. So CBD is this angle here. So why is that 90 degrees? Well, it's a circle theorem. It's because CD is a diameter. Or DC, doesn't matter, whatever you want to say. So DC is a diameter. And it's a circle theorem that any angle subtended by a diameter is 90 degrees. So it has to be 90 degrees. That's a a circle theorem, so it's in your book, so you can look it up, and it's just stating that. Hence, we have to prove that the triangles BCE and DBE are similar. Right, well, BCE is this triangle here, and DBE is that triangle there. So we just need to be similar, the angles need to be the same. Well, we know that there's a right angle in two of them anyway. So the angle CBE is equal to the angle DEB. They're both 90 degrees. They're both right angles, or 90 degrees. Then now actually we can't say any of the other angles are equal in this so far, because there's no other reason why any of the other angles would be equal from just examining those two triangles. What you have to do here first is, we'll get rid of that for a second. You're going to show that the triangle BCE, so we'll just show that that triangle is similar to the big triangle, to this triangle here. So we'll just show that those two are similar first. So the angle CEB is equal to the angle CBD. So both of those are right angles. Then you can say that the angle DCB is equal to the angle ECB. So I'm talking about this angle up here in both cases. That's the same angle. It's just labeled differently from different points, but they have to be equal because it's the same angle. Then because two of the angles in it are the same, the other one has to be the same as well. So other angle must be the same. Now that shows then that those triangles are similar. So the triangle, the ones I've just said there, BCE, so that has to be congruent to the triangle CBD. Then, so we've shown that those two triangles are similar. Now I'm going to show that the bottom triangle down here, so that this one is similar to the big triangle also. So to do that, then we know that the angle DEB is equal to the angle, the right angle, so the DBC in the big triangle. And we also know that the angle CDB is equal to EDB. So CDB is equal to EDB. again they're the same angle. And the same reason for the top one as well is that they're right angles. Right, therefore, because we've shown that, we've basically shown that this triangle is congruent to the big triangle, and we've shown that this triangle is congruent to the big triangle. Therefore, because they're both congruent to the big, or not, sorry, I shouldn't say congruent, I mean similar. Therefore, they're both similar to the big triangle, therefore they're similar to each other. And then other angle is the same as well. Yeah, sorry, not congruent, so similar. Right, the top cone has a radius of r and a height of h. So if you label them on the diagram, then so EB is r, EC is h. Right, well, if the diameter, then the radius they're saying is 10 of this circle S. So what they're saying is that the whole way down there is has to be 20, then all of that has to be 20 because that's the diameter. Therefore, the bit down at the bottom, this bit here, has to be 20 take away the h. So we can put 20 take away h in there for that. Now I'm just going to draw them out separately here. So if that's the triangle CEB, that's just copying it across, that's exactly the same orientation as it is. Then the other one, we have to rotate that around just to make it look like that. So I'm basically taking that there and just rotating it around to the left. Therefore the B ends up here. The E is at the right angle, and the D is here. Therefore, if you mark in the sides now, this is 20 minus h, and this is r, and then the other one, it's just as it is, so that down there is r and this is h. So it's easy to compare them then, so they're similar triangles. Therefore, we're going to take the ratios. So if I take the bottom of both, the bottom of the first one is r and the side of it is h, so r over h, that has to be equal to the bottom of the second one is 20 minus h, and the side of the first one is r. Therefore it should work out nicely then. If you just cross multiply there, then you get r squared is equal to, and you're just multiplying h by both of them then, so 20h minus h squared. Then hence write the volume of the top cone in terms of h and pi. So volume of a cone then is 1 over 3 pi r squared h. We're just going to be filling into this then, so 1 over 3 will stay the same. Pi will stay the same for now. Now r squared is what we have to see. So r squared, we've already worked out what r squared is, the whole of r squared, not just r. R squared is 20h minus h squared. Therefore I'm going to put that in 20h minus h squared, like that, all in for r, and we still have to multiply by h then as well outside. I can multiply the h then in just to simplify it a little bit. get that. Now, because it's maximum, we're going to differentiate and we're going to let it be equal to 0. Anytime it's max or min in a question, a lot of the time it's going to be, we do that, we differentiate and let it be equal to 0. So I'm going to find dv dh here. I should probably have multiplied the 1 over 3 and the pi in first. So that would be 20 over 3 pi h squared minus 1 over 3 pi h cubed. To differentiate that, then we're going to get, it'll be 40 over 3 pi h minus 3 times a third is just going to be 1, so we're just going to get pi h squared there, and then we're going to let that be equal to 0, and we're going to solve then for h. The pi's will cancel out, you can just divide across by pi. If you multiply across by 3 actually, you'll get 40 minus 3h squared is equal to 0. 40h, and then if we take out the h out of both, so we get h times 40 minus 3h. One of them has to be equal to 0 then, so h is equal to 0, or 40 minus 3h is equal to 0. Bring the 40 to the other side, we get minus 3h is equal to minus 40. So then h is equal to 40 over 3. Forty over 3 then will be the maximum. So you could, if you wanted, find a second derivative of what was up there, and then sub it in. So it would be 2 pi h, so minus 2 pi h plus 40 over 3 pi. That would be the second derivative, and put in the 40 over 3. It will give you a negative, so that's the max then.